Let's talk about the convective windstorms forecasting. As we all know, at the precipitation developing stage, it is often another fundamental element of a storm commonly forms, the convective downdraft. Once the downdraft reaches the surface, it spreads out and produces a gust front at its leading edge. In some instances, however, the intensity of these downward motions and the subsequent outflow winds within these storms can result in severe damage. We call the convective windstorms, which are referred to as downbursts, microbursts, and derechos. Many studies have illustrated the importance of the downdraft and the outflow it produced in severe storm research. It is instructive to understand the forcing mechanisms that create a downdraft, and outflow studies suggest that the most downdrafts are driven by cooling from phase changes. Although condensate loading typically has a secondary effect, it can be important in initial downward motion. Entrament can also initiate downdrafts. The outflow of downdraft air from thunderstorms is an important phenomenon in convective storm dynamics. The leading edge of the outflow is often referred to as the gust front. Moving fast gust fronts suggest strong outflow. The outflow from thunderstorm has been shown to be dynamically similar to the density current. So, for strong downdraft, pay attention to cooling from phase change entrament, and for strong outflows, the density current and the gust front. This is my work that analyzed environmental parameters of severe convective windstorms, which we choose the wind speed greater than 25 meters per second in China in 2004 to 2013, almost 10 years. By analyzing the environmental parameters of 3 different cloud patterns in eastern China, where severe thunderstorm winds are often seen, we found that we use the temperature dew point of the surface and the difference between temperature and the dew point in 700 millibar, 500 millibar, and 400 millibar, and the temperature differences between 700 millibar and 500 millibar. From this analysis, we found that in all cases there were high lapse right below the middle troposphere and obvious dry layer in the middle troposphere. But from these 3 different cloud types, we found that the variance of humidity and temperature in low level for the single convective cloud pattern and cluster clouds are large and also with high lapse rate. In comparison, look at the vertical wind shear in the low and deep layer. For the line cloud pattern, the value of low level and deep vertical wind shear are large, and the whole layer is dry, but the thermodynamic parameters are smaller. The ambient vertical wind shears for the single convective cloud pattern are smaller. An important aspect of severe storm research is the ability to transfer this knowledge into improved forecasting of thunderstorm initiation and subsequent high wind events. According to the research, 3 aspects of favorable environmental conditions of convective windstorm are as follows: obvious dry layer in the middle troposphere, high lapse right below the middle troposphere, and high vertical wind shear. Fujita coined the term bone echo to identify a bone-shaped line of echoes that appear to be associated with numbers and directions. Other investigators have subsequently confirmed this relationship. This is a research of Lin Zheng in 2013. They found bone echo and pure line echo generate extremely high winds. Even greater than 24 meters per second. Also, for convective windstorms, a systematic, comprehensive analysis forecast process includes synoptic and mesoscale analysis to help us have awareness on expected convective windstorm severity. Then, after checking the current conditions at the surface and aloft, and then comparing them to the model forecast initial conditions of the 0-hour forecast, we decided that they are close enough to allow us to trust that the models are at least starting off well. After analyzing the model mesoscale analysis and sounding analysis of variable environmental conditions for convective windstorms, we also pay more attention to the echo mode, moving speed of reflectivity, and surface wind field from models. Here is a case in Hebei on June 22, 2014. The upline is a satellite image, and the below is radar reflectivity from the satellite, and the radar images from 14 to 20 CST. Bone echoes embed in a score line because the convective high wind in Hebei. Look at this moment. The bone echo show me the organization of the thunderstorm. Soundings measurement taken in Xinhai at 8 o'clock CST. Xinhai is located here. We talked about before. The sounding indicates CAP of 674.3 joule per kilogram. The height of the weight bulb zero temperature is 4.3 kilometers. The surface to 6 kilometers shear is 21 meters per second, which is very high in this moment. The temperature difference between 700 millibar and 500 millibar is 18 degree. High left red air in the lower middle troposphere above. When the low-level moisture becomes high, it will create the extremely CAP values. Also, we look. There are dry layers in the middle troposphere in the red circle, and the high vertical shear indicates the favorable environmental conditions for high winds event. These are the model composite reflectivity forecast at the initial time of 20 o'clock CST on June 21. The left is at 14 o'clock CST, the middle is at 17 o'clock CST, the right is 20 o'clock CST. From these 3 hours, similar bone echo embedded in the linear line pass from center of Hebei to the southern part of Hebei. Look at this image, bone echo, and at 8:20 o'clock, the bone echo embedded in the linear line passed quickly. The echo mode is bone echo, or bone echo embedded in the linear line. There are the model composite reflectivity forecast at the initial time of 20 o'clock CST. The left is at 17 o'clock. The right is at 20 o'clock. So we'll pay more attention to the echo mode. In the left image, the bone echo, and in the right image, the multi-bone echoes. From 17 o'clock to 20 o'clock CST, the obvious bone echo indicates the possibility of convective windstorms. Also, let's move to the moving speed of convective systems. These are the same two images. From 17 o'clock to 20 o'clock CST, we calculate the moving speed of the convective systems. It is almost 50 kilometers per hour. So this high speed indicates that the high possibility of convective windstorm. These are the model surface wind field at the initial time of 20 o'clock CST on June 21. The left is at 14 o'clock, the middle is at 17 o'clock, the right is 20 o'clock. So we see from this image there are strong winds on the ground, and move to the 20 o'clock, the strong wind band southeastward, and they are obviously straightened. So from 14 o'clock to 20 o'clock. Let's see more details in the surface wind field at 17 o'clock and 20 o'clock. In these 3 hours, the obviously straightening wind band southeastward indicate high possibility of more than 20 meters per second convective wind. This is the convective weather report from 17 o'clock to 20 o'clock on June 22, surface observations. So we see that Nangong in Hebei province have the convective wind greater than 24 meters per second. So the surface wind field performs well in the intensity and the location forecast. Another case is in Shanxi province on June 24 this year. From the real radar image from 14 o'clock to 20 o'clock CST, we see that bone echoes embedded in the score line cause the convective high winds in Shanxi. This is Shanxi province. Starting with measurement taken in Taiyuan at 8 o'clock CST, we look at this image. Taiyuan is located here, indicates CAPE of 111 joule per kilogram. The height of the weight above zero is 3.8 kilometers. The surface to 6 kilometers shear is 13 meter per second. It's not very high, and the lapse rate is very high. So the high lapse rate air in the lower middle troposphere above, when the lower level moisture become high, it will create extremely CAP values. So pay more attention to the high lapse rate. And also dry layer in the middle troposphere in the red circle. In the left, it is the soundings of Shanxi at 8 o'clock, and in the right, it is the wind field from Beijing, RMFST in 500 millibar from 14 o'clock CST to 17 o'clock CST on June 24 at the initial time of 8 o'clock CST, indicates that we see in the red box the wind shear will intensify even greater than 20 meters per second. which let us inspect the organization of thunderstorm, maybe subsea or squall-line. So, high left red air in the lower middle troposphere above and dry level in the middle troposphere. High expected vertical shear indicates the favorable environment conditions for high wind events. These are the model composite reflectivity forecast at the initial time of 8 o'clock CST. The left is at 14 o'clock, the middle is at 17 o'clock, right is 20 o'clock. From this model forecast, similar bone echo embedded in the squall line passed from Neimong to Shanxi. So the echo mode is squall line or bone echo embedded in the squall line. These are the model composite reflectivity forecast at the initial time of 14 o'clock CST, the very nearby time, so the left is at 15 o'clock and the right is 17 o'clock. From these 3 hours similar bone echo embedded in the squall line passed as velocity of 15 km per hour suggests a high possibility of thunderstorm and high winds. These are the model surface wind field at the initial time of 8 o'clock CST. The left is at 14 o'clock CST. The middle is at 17 o'clock CST. The right is 19 o'clock CST. We see in the red circle, there are strong winds on the ground, southeastward, and they are previously straightened from 14 o'clock to 17 o'clock. These are the model surface wind field at the initial time of 11 o'clock CST. The left also is at 14 and the middle is at 17. The right is at 19. We also see that the same area, the strong wind on the ground southward, and they are previously straightened from 14 to 17, which indicates that high possibility of more than 16 meters per second convective wind. These are the model surface wind field at the initial time of 14 o'clock in afternoon. The left is at 17 o'clock. The right is at 19 o'clock. So we also see that the south of this squall line, the surface wind field suggests that there are also strong winds on the ground southeastward. From real radar image from 14 o'clock CST to 20 o'clock CST, bone echo embedded in the squall line caused the convective high winds in Shanxi. So the model 3 kilometers model behaved very good in this case. In summary, also firstly, for convective windstorms, systematic comprehensive analysis forecast process includes synoptic and mesoscale analysis to help us have awareness on expected convective windstorm weather. Then, after checking the current conditions at the surface and aloft, and then comparing them to the model forecasting initial conditions of the 0-hour forecast, we decided that they are close enough to allow us to trust that the models are at least starting off well. After analyzing the models' mesoscale analysis and sounding analysis of favorable environmental conditions for convective windstorms, we need to pay more attention to 3 aspects: obvious tri-layer in the middle troposphere, high left thread below the middle troposphere and high vertical wind shear. We also pay more attention to the echo mode, bow echo or linear line, moving speed of reflectivity, and the surface wind field from models.